Welcome everyone. We're up to, well, I'm going to say on a sub-track here to do with generative geospatial. We're up to episode 4, and I'm proud to say we have from England's Ordnance Survey, Steve Atwell, to talk about OSM AI map and some other activities basically that he's been advertising on Twitter. So welcome, Steve. Thanks very much for joining us.
Cheers, Will. It's nice to be here. Thanks for inviting me on. I've been looking at some of the other podcasts that you've done with great interest. It all seems to be about geospatial and AI at the moment for you.
Sure. Yeah. Trying to keep up with the times. So would you like to tell us a little bit about why you decided to start applying ChatGPT and GPT-4 to what you do at OS and to geospatial generally?
Yeah, sure. So I'm a user experience designer. I run the user experience design team at Ordnance Survey. And for those that don't know, maybe the global audience, Ordnance Survey are Britain's mapping agency. So at top of my mind, generally in my team's mind at work, is how can we make geospatial data easier to access? So for many years, there's been kind of in the back of my mind this idea that there might be a text box that you could just write your query into and gain an answer or a map from that query. I mean, it's been kind of like a long-standing thought with no way to enact it, really. No easy way to enact it. So I've been doing lots of kind of out of work experiments. So the things that I've been doing with OpenAI and ChatGPT have all been outside of work experiments, which is nice because, you know, work is so structured and we work in such a structured way, and we need to be mindful of all sorts of rules and regulations. Whereas if you kind of do things outside of work, you can be a lot freer and it can be a bit more of a free artistic endeavor. But it is kind of leaking now back into work again as we kind of look at how that might affect, how the advent of artificial intelligence might affect, or should I say really large language models might affect kind of Ordnance Survey's ways of working in the future. So really it was testing out ideas at home, and the first thing I thought really was, you know, I wonder if ChatGPT knows anything about location and location intelligence, because that's where we sit all the time. Does it know anything about that? And in fact, you know, if you ask ChatGPT some information about a location, you get very varying results. And then this was back kind of before GPT-4 came out and before 3.5, so it was the version 3. And so part of my kind of investigations of how that works, does it know about Ordnance Survey? Does it know what we do? Does it know why geospatial intelligence is useful and geospatial data is useful? And then kind of, does it know the 3 busiest roads near me? You know, that's a typical question that you might want to ask, even from like a personal point of view. And it gave some reasonably convincing looking answers, which I couldn't really verify whether they were true or not, because the
constant issue. Yeah.
Yeah, the constant issue is it hallucinating at me? But it knew it. I know my local area, so I know their roads and I know their busy ones, and it had, you know. So then I thought, and then
did it give you a correct answer?
It gave me some convincing answers. Yes.
Yeah.
I would, you know, it picked out what was definitely, you know, the M27 near us, the motorway is definitely the busiest one and causes the most delays, and then a few in the local area. Yeah, it named roads that I know are very busy and like a problem to travel down. So then kind of looked at, because I started using it to help me program other things like JavaScript. You know, I was getting it to write JavaScript for me to like up my pace of being able to do little demos and things. I learned that it would then it would be able to respond with data files rather than text. So rather than saying I want, you know, tell me in text format, which is this natural kind of way of responding, what these 3 busiest roads are, respond to me as a JSON file or a table or a CSV file. And through watching what other people were doing on Twitter, kind of learning, okay, well, if it can respond with a JSON file, then can it respond with a GeoJSON file, which is a geospatial version of a data file? This is getting a bit technical, but you can just think of it like an Excel spreadsheet.
Please get technical.
Yeah, it's a bit like a CSV or an Excel spreadsheet or something. It just is something that a computer can then interpret rather than you reading it. You can do something with it. And GeoJSON is kind of a list of names and locations. So does it know the locations? So it's kind of this slow, methodical kind of wondering about and noodling around with it and finding out what's useful and what isn't. And from there, looking at if it seemed to know some train stations near me, can it tell me the Latin long coordinates? And that's where it got really stuck. That's when you suddenly realize that it can give you some convincing arguments of some things that are near you, even if you're in like a relatively remote place. But when it gives you coordinates, unless it's somewhere like Heathrow Airport, which it can nail, if it's my local 3 train stations, it kind of just says, oh yeah, and it puts 3 dots roughly in the town, like roughly next to each other. They're actually like in a line, so you can tell it's making things up.
But it's still relatively close to vaguely where you are.
Yeah, it's still like because it's still kind of like smack bang in the middle of the town, really, rather than actually being where the train stations are. And look, really varying results of that. So we were kind of getting somewhere with that in the evenings, looking at various ways of doing it. And then, the big kind of breakthrough really was watching what other people are doing when they're trying to when they're using ChatGPT APIs to create SQL queries, which are queries which like will query a database, which are like select star from users, select everything from the users table where the user spent this much money, and then you can get some intelligence about that. So I kind of used and a lot of geospatial APIs will use a similar kind of method of talking and to the backend database, and OpenStreetMap is one of those where you can query it using a similar language. So I started using it rather than just asking it directly to give me train stations, to build queries to OpenStreetMap so that I could then use that query to get the data and put it on a map. I think I'll stop there in case you've got any other questions, because
no, that's
you
good.
can keep going.
That's genuinely an origin story. You have told us the story
exactly.
of the origins of OSM AI map. Okay, so we're still to carry on. I have to ask the next question. Did you follow tradition and make ChatGPT or GPT-4 code OSM AI map for you from a paper sketch as they demonstrated online when it was released?
No. Like we use pencil and paper a lot at work, but when I'm building tools, and if you kind of look at my Twitter feed, there's all sorts of mapping tools, and they're all bizarre things all over the place because I use it as a creative outlet as well. When I do that, I go straight to HTML and JavaScript and CSS and start building things and noodling around directly in that, and they grow organically. They never get big enough really to have to start designing them in a formal manner, because if that happens, something really good has happened and we need to kind of stop, take stock and start again. These are all just held together with string and sellotape, these demos. They really are.
Sure. Yeah, I think that was a real moment for me watching the GPT-4 intro video, where he just showed basically a photo someone had taken of proposed, layout for a simple web page. I think it was about jokes or something. Press a button to get another joke. Someone in Geospatial will get it to produce a map that way.
Yeah, I definitely the demos that I've built, I used it a lot to write a lot of the code, and it significantly increased the speed at which I could get a demo out, because I've been doing this since the start of lockdown. Is you know, building things in browser and noodling around with maps and things like that in my spare time. And honestly, the rate at which you can build something is so much quicker if you get help from ChatGPT.
Yeah, that's there's a couple of patterns that are emerging here in this sub-series, as I said, about generative geospatial. I'll say in our interview with Melinda, who was a co-founder of Proxy, she started Maps GPT. She also said that she used ChatGPT a lot to speed up her development of that tool. And another theme that's coming out is using ChatGPT or some sort of generative AI for geocoding. And you're the first one to talk about trying to or seeing what the coordinates it produces, what that results in on the map. So yeah, that's interesting. I'll have to do the same.
Yeah, that's good.
Yeah. Okay, so perhaps we can dig into this tool you've developed a bit. So what are the steps that the tool goes through to convert natural language to points or building footprints on a map?
So I've built a couple of tools. There's one with OpenStreetMap data, and then I've gone and then I've built one that queries Ordnance Survey data as well. And they both work in slightly different ways. One is a slightly more dangerous, maybe slightly irresponsible way, and I found that there could be significant risks in developing it that way, and the other way is really, really safe. So it's worth like looking at those two different ways, really. So the OpenStreetMap was where I started, and what we're basically doing there is using GPT-4 to help us write a query to a database. That's what we're doing. So in both of these examples, they don't actually go and get the data. All they do is help you formulate, you know, a request to some data on the fly. So, and the way that practically happens is in the OpenStreetMap one, we're trying to get to the point where we've got an API call, which will go and get some features, and then we can then turn back to traditional programming kind of methodology, then go and grab those features and put them on a map. And the trick is to do that in such a way that somebody is going to find it very difficult to abuse that system. And also, can you get it to consistently do that every time? And can you make it slightly more intelligent so that rather than just returning buildings, it can return buildings within a distance of something else, which the OSM API can do. I had to learn how to use the OSM API, and it's very difficult. I found that probably more challenging than anything else.
I've heard that the Overpass API I've heard is almost unintelligible.
It's tricky. I found some good online examples of how to make a good query, and basically the idea of the demo is that you type anything you like into a box, hit go, and it will try and return something from OpenStreetMap. So, for instance, you can put in something like minor roads. And now I don't think there's a particular feature in OpenStreetMap called minor roads. That's kind of a thing where you might want A roads, B roads if you're in the UK, and maybe footpaths and things like that, but not up to motorways. So you're typing something in, and then we're asking the AI to look at that term. And because it has a general knowledge of OpenStreetMap and the data that's within it, asking it to evaluate popular things which it knows to exist, and this is literally how the prompt is written, popular things that you know to exist within the OpenStreetMap database, and write a query that does that. And here's 5 query examples. like his 5 sentences and their query examples that I would expect back. And that's how it works, really. And one of the things to get rid of hallucinations I found was to ask it to. I asked it what are the most popular things in OpenStreetMap, what are the most popular features, and it seemed to know. So I incorporated that into the query and said only return things which you know are in there, and that seemed to reduce the hallucinations of things it was trying to find.
Okay, so I guess at some point we might have a screen sharing session and see maybe and also describe importantly, whilst you're demonstrating that, what you've built up out of all of these late nights checking what you can do in with this generative approach or with this large language model. But if I can sort of sum up over, it sounds like a number of months of investigation, step by step, of the capabilities of this large language model, checking the amount of detail and the accuracy of the geospatial data that it holds, you came up with an idea for a simple tool for to use the large language model to retrieve from OpenStreetMap things that you're asking using natural language. So basically the idea is that the large language model does the complex work of forming a query, which can be hard for a human to formulate without a lot of patience and training. So you're getting the large language model to do that, and then displaying the results on a web map. Maybe that's a bit longer of a summary than I. Perhaps you can summarize it even better.
Yeah, I think you summarized it really well. And the magic of the whole thing really is you can type anything into the box and the AI will try and interpret it for you. So if you type in libraries, it will try and find some libraries for you. If you type in where can I park my helicopter, it will find helicopter pads, and if you type in days out, it'll make some interpretation of that. So I couldn't guarantee to you every time that it's going to return what you expected, but it seems very reliable, to return not just features, map features, but also things related to activities or thoughts that you might have. So it really is lowering. I mean, we talk at Ordnance Survey a lot about kind of lowering the barrier to being able to use geospatial data, and the path to value being as short as possible. So you have the data, but the path to you getting valuable insights out of it is as short as possible. And so that's what's always at the back of my mind doing this. I mean, it's part of it is play, part of it is playing around with these things and trying to understand how they work, but also in the back of my mind, I have real world use case scenarios for, maybe emergency services, disaster scenarios, because that's a good example of somewhere where there's lots of information coming in from different places at random times with different levels of accuracy and reliability. When, say, if there's some major emergency within the UK, there'll be a disaster response team which gets together and kind of manages that response. And being able to interpret natural language at that point and interpret lots and lots of data, which is where this is all kind of going to go, in a very naturalistic manner from all sorts of reports from all sorts of reliable and unreliable sources, is something which may, be in the future very, very useful and a use for AI. I don't think we're there yet, but that's the kind of thing that it could be really useful for.
Yeah, okay, so that makes me think of another geospatial initiative that's come out of the UK. What 3 words? As far as I can understand, that converts the whole planet into, is it 10 square meter squares? Something like that. And
like that. Yeah, I don't know.
Yeah, and 3 words that are supposed to be easier for a human which speaks, well, English or whatever language is being that those 3 words are assembled from, those are supposed to be easier for a human to remember and understand and recite under stress to emergency services. So it's really interesting to think of a large language model as being a replacement or the next step.
Yeah, and then there are all sorts of instances where someone might want to interrogate a map and not have the knowledge in order to interrogate that in a technical manner, because you know you do need right now you need unless somebody's built a very intelligent and clever tool on top of it in order to interrogate data and get value out of it, especially geospatial data, it's difficult. And to be able to ask it anything would be wonderful. And I think we kind of, the demos that I built are like a tiny little step towards that. And yeah, I've learned a lot along the way as well about what you can and can't do and what's risky, and the differences in whether you need to put more work into training it on your data as well. So that's an interesting kind of area, because you can assume that ChatGPT knows quite a lot about OpenStreetMap and its data, because all the information has been publicly available for a long time. It seems pretty good at writing queries if you give it a few examples of what you expect back from it. But then if you look at Ordnance Survey data, especially the new data that we've got and our new APIs, it doesn't really, well, it won't know about a lot of our newer data and our newer data formats, because they were released after it's been trained. So that's where you have to start using slightly different techniques in order to try and get it to return something useful.
Yeah, I mean, suddenly I feel like there's a few different directions we could go in with this conversation. I wanted, though, to return to a topic that I think a lot of people might be interested in, which was the lessons you might have learnt in how maybe the AI can fail when you're trying to use it. And the way I thought we could get into this was, given that you're using GPT to form queries against OpenStreetMap,
yeah.
I think when I tried to use your tool, I asked for pie shops within 200 meters. So if I ask that same question 50 times, will it form the same query 50 times?
Maybe not. There are ways to help it return the same response. So turning, I think it's the temperature down to 0, means it gets very formulaic and not creative in its answers, which is something, if you're asking it to return things like queries and something that you're going to then use in a programming language to query a database with, you really want it not to be creative at all and be consistent. So, and the temperature is just an option that you can set when you're asking the AI something. So, and it depends as well if you move the map. So it's not just about ChatGPT and whether it will be consistent in its answer. Sometimes it might be consistent in its answer, but OpenStreetMap won't be. So there's that as well. So OpenStreetMap obviously is open source data, and it's a wonderful resource of data. However, if you ask for pie shops in one town, whoever mapped that town and open source kind of mapped that might be really interested in pie shops, and they're all there. But you move to another town where they hasn't been captured, maybe not even all the buildings or shops have been captured, and so the results that you get back are not necessarily consistent. So although OSN gives you this wonderful way of interrogating the data, you do need to be aware that for commercial purposes, or for maybe emergency services purposes, which is kind of in the when you talk about like how useful is data and how reliable is it, if you want to get an ambulance from one place to another, you have to have all of those buildings mapped properly and all the addresses exactly in the right place. So maybe using OpenStreetMap is not the wisest choice in that scenario. So
sure. I guess I was meaning, yes, and definitely, and you're reminding me of the fact that you and me and every other OpenStreetMap user has the right to produce new tags, and they might be about the same thing. So there's that. There's many degrees of freedom that OpenStreetMap users have, and that is a double-edged sword. I guess, yeah, I was more perhaps meaning in terms of the ways that sometimes unpredictable ways that ChatGPT can respond. You mentioned one about making sure you only ask it for the popular ones that are nearby.
Yeah, so encouraging it in the request to kind of stick to things which actually exist. It sounds weird, but if you don't ask it to return things that exist, it sometimes doesn't. So that seems to have kind of cajoled it into a more reliable answer. And
Yep.
also, and it's really interesting how by giving some example queries as well, like 3 or 4 example queries of how to return a building, how to return a building that's close to something else, those kinds of queries, giving it that example will really help with its consistency as well.
So you're saying when the prompt is submitted, you have a well-formed query that goes along with that prompt that it then uses to model its response.
Yeah, I send 3 over. I tell it exactly what I want it to return, which part of the query I want, where it's going to go in, in the whole URL that I'm going to use it for. And yeah, these examples, which are based on the research that I made, and trying to find out good examples myself to return simple, reliable requests back from OpenStreetMap.
From a naive outsider's perspective, I mean, this is just another example of how it's almost like talking with another person. I feel like you've heard of the Turing test, I imagine.
Yeah.
I feel like we've crossed the chasm.
It really is. I mean, somebody was talking to me. We had a little kind of semi-unofficial event about OpenAI and artificial intelligence at work the other day, and people were talking about hallucinations. And I draw the comparison to children. So if you ask a child a question and they know the answer, they'll tell you the answer. If you ask a child a question and they don't know the answer, they'll still tell you something. And that seems to be, in a simplistic sense, how ChatGPT behaves. It will try, unless you tell it, if you don't know the answer, don't say anything, which you can do, and that can reduce hallucinations. It will always try and please you with an answer, it seems, sometimes.
I mean, I have a 2.5-year-old daughter. Teaching her words from a book, she even does the same. When she doesn't know the name, I don't know, a raincoat. She'll make up something, or she'll say that, or some word will come out. It's I don't know. It's very tempting to begin to anthropomorphize it. I'll say that, and that's an interesting position for. At the risk of sounding too expansive, an interesting position for humanity to be in.
It is, and I know that people kind of talk about these artificial intelligence or these large language models as if hallucination is a problem. But I have conversations with people every day where I don't get the full truth, or I get things which are slightly misrepresented, and you have to be intelligent about what you take on board and what you don't. And even more so maybe with ChatGPT and checking sources, making sure it's reliable. I think there's this assumption that because it's a computer, it's going to know the answer to everything, and just making sure that we don't assume that is a very healthy position to be in, I think.
Yes, so from a critical thinker's perspective, the authority bias is something we have to have in mind here. Yep. Okay. So then it looks like, again, to try to sum up, we appear to be confronted with something that in some way can pass the Turing test. That somehow can act as an interpreter between humans and computers, And instead of the humans having to learn the computer's various languages, the computer in this case appears to have learned part of our language. And it's got us to the point where it's tricking some of us into thinking that there's something more than just a machine there. So the result of your efforts here are for it to take a string of text in a text box that's expressed in our natural language and return some assets, I can say, or records from the OpenStreetMap database. I gave the example of my vain attempts of pie shops. Okay, and that's within the map frame that the map is centered on using your tool. Okay, so to lighten things up a bit, given that we're starting to get a bit existential there, what are some of the strangest uses of the tool that you've made, or the strangest outcomes of using it?
I'm not sure. There's so many strange things. I mean, trying to ask it things that you wouldn't expect. I mean, my mindset is when I ask it things is a little bit formulaic, and I have to remind myself, like, I just ask it some random stuff, like, where can I park my helicopter? What's it going to do with that? You know, will it respond with anything at all? Is it going to go airports? Is it going to try and find just helipads? And how can I kind of adjust how creative it's going to be with its answer? You know, that might be a time when you do want it to be a bit more creative. But actually, most of the things that I've been putting into it are kind of not that fun.
Okay.
So they've been more business oriented. I must try some more things. I did ask it, you know, places my mum might like to go for the afternoon, and it gets me, you know, some historic houses, libraries, some shops nearby, stuff like that. And it's quite a broad like set of things that it will try and return. And that was using the Ordnance Survey version of this, which works slightly differently.
Okay, so then I mean, this could be the wrong way to put it, but to me, that's an example of semantic processing. It's interpreting the meaning of, you know, what your mother might be interested in seeing. So that to me is maps onto semantics, and then it's doing syntax. So it's converting what that meaning is that it's interpreted into syntax. Or interesting.
Yeah.
Okay. So I guess in the discussions you have been having at Ordnance Survey, have you or anyone else thought about the next step, which is spatial analysis? For example, you know, in terms of geospatial, a classic is multi-criteria analyses.
I've got that in mind at the moment, but from a really simplistic sense about trying to get it to return things that are related to other things, because that's kind of the first level, or things which have a certain property. So hills that are over, you can ask it hills that are over 500 meters high, or buildings that are lower than, you know, whose height is less than this, and also, you know, buildings that are within 200 meters of the coastline, and you can kind of see the relevant applications of that. And buildings that are within 500 meters to a supermarket. So those are things that you can ask it right now, and you can imagine, you know, if you're planning shops and, you know, planning where you're going to do your business, you can just ask it, you know, or basically whatever query you want to say, well, which houses are outside this mythical zone of 500, like walking distance from all the supermarkets that you've got near you.
To me, that's the first instance of geospatial as a profession being confronted with evidence of how a large language model can take away jobs.
Yeah,
because you know, it's the classic where can I position the next Sainsbury's, which is a supermarket chain in the UK for our US listeners, and it's sounding to me like that can already be done without a human intervening.
Kind of. I wouldn't rely on the data. I wouldn't 100% rely on that data, because you could get a general gist for a lot of things. I mean, maybe that would be okay in certain circumstances in certain areas of the country if you're using OpenStreetMap data. But yes, what it does is it moves the it moves the power of who can interpret that data from one place to another. And it moves it, and it basically, what I'm saying is it democratizes you being able to ask those questions. You still have to have you still have to know what question you want to ask it, understand why you're asking it that question, and be quizzical about the answer that it gives you back. But yeah, it's going to lower the barrier to being able to get useful answers out of that, definitely.
And that immediately makes me think the next batch of entrepreneurs or the next bunch of geospatial startups should have a large language model at the core of their architecture. It seems like it would be just as nonsensical to have a geospatial startup without CPUs or without the transistor.
Yeah, I mean, you can, and it really, you kind of nailed it in one of your previous answers or your summaries, which is the fact that it is interpreting what you say into the ability to be able to get that out of something that's actually quite a technical endeavor to get that answer out of something. But it's not magic, so it needs certain other technical layers to exist, and those are difficult to stack up reliably. I think that's where when those are in place, that's where a lot of the value has to come from. So you need a reliable data set to begin with. Okay, so we've already talked about that. How can you get that reliable data? You also need a way of querying that. You still need a way of querying that data. You need some avenue, some API, or you need to have ingested the data into something else that you can then ask questions of it. None of that changes whether you've got AI or not. Those things always have to exist already for you to get data out. And the weird thing about doing those two demos, one with OSM data and one with Ordnance Survey data, is Ordnance Survey have this amazing layer of highly accurate, reliable data, which is up to date. But it's more difficult it doesn't have the Overpass API on it. So there's only certain things that you can actually query from it, because we're kind of, we're moving from being this data provider to trying to get our customers to get more information out of that data quicker. Whereas OSM has got this great API where you can actually make geospatial queries with it to a degree, but unfortunately the data underneath it for some applications is fantastic, but for other applications it's not quite reliable enough or coverage enough coverage. So I mean, you could argue the same with Ordnance Survey data, because that's pretty much that's Great Britain and nowhere else. So you have to kind of equate them to any kind of national mapping agency around the world.
Sure. Okay, I'm realizing we've gotten this far, but we haven't actually seen what you want to have developed. Shall we share screens for 5 minutes or a couple of minutes?
Yeah, let's do that. Yeah. So I mean, this is what we've been talking about, and you might type in something like, and this is the OpenStreetMap version. So you might type in something like main roads. This actually uses ChatGPT-4. Whereas the other demo I'll show you uses 3.5, and there's a 10 times difference in cost for those things. So to write these API queries, you need the more expensive version, I found, to get a reliable answer out. So we can say, okay, there's some main roads there, which is interesting. And what it's actually writing, if I pick this up for all the nerds out there who are into their Overpass API queries, it's actually writing from this question mark to the end. And it's interpreted me saying main roads as highways which are labeled motorways, trunk, or primary. Seems pretty convincing. If I said trunk roads, it would get trunk roads. So,
and if you just pan the map a bit, it's orange colored. You can see the tag for the A320. Yeah, so in the symbology on OpenStreetMap, those are orange roads. So clearly those, yeah.
Yeah.
Main roads. Yep.
That's right.
But matches up. Yeah.
So if you use something like, you can ask it things like supermarkets, and it'll go away and get you some supermarkets. It tends to take about 10 or 15 seconds to do this each time. There you go. It's found a couple of examples there of supermarkets, and it's returned these not as lines but as, you know, polygons. And that there is an Aldi. So okay, so let's say I'm trying to plan my supermarket. I can say, you know, buildings within 400 meters. Aldi.
And it will take Aldi within the map frame that's currently in your view on the map.
Yeah, it will take, yeah, so it starts with Aldi, finds all the Aldis in your map frame, and then finds all the buildings that are around it. So you can see that this is what it's written. So that part from data onwards, it finds the supermarket with a name of Aldi. I didn't tell it was a supermarket, actually. There's no history, there's no memory on this one either. It's taking this as it is. So it obviously knows Aldi's a supermarket. And then it's basically, and that's the map frame. That's the coordinates of the top left and the bottom right of the map. And then it's saying, and then find everything that's around 400 meters of that that's labeled building.
Okay, and just to fully describe what's on the screen here, so it's then highlighted in red for those listening on the podcast.
Oh yeah, I forgot about that. Yeah.
All the buildings within 400 meters, and it's a nice circle roughly around in terms of what the building footprints are available within 400 meters of that Aldi. A circle is visible on the map, or a disc, I should say.
Yeah, like a disc. Yeah. So you can see how you could start using this. I mean, I am, to a degree, I'm cherry picking some examples here, which I know are going to work because we're doing a podcast at the moment. So yeah, it comes back with interesting answers if you ask it within and near and over, that kind of thing. And then I obviously showed that to some people at Ordnance Survey, and they said, well, we've got this new database called the NGD, the National Geographic Database. Can you get it to interrogate that? So then we had a look at kind of putting the Ordnance Survey base map on there as well, and trying to get answers out of that. And I basically taught it one of the data layers. So it looks at the Ordnance Survey sites layer, because that contains things like police stations and power stations, and historic buildings and things like that, and libraries. So and again, here you can ask it things like emergency services. So I'm typing emergency services into the box, and then we're waiting a few seconds, and it will go back and find 11. It's found 11 features within my map view of Southampton. And if I open up this, it will tell us what it's found. So it's found police stations, fire stations, and police support sites. So there's there's nothing in our database labeled emergency services that I've typed in. What we're using ChatGPT for here.
So that's another example of semantic processing.
Exactly.
Ahead of syntax. Yep.
Yeah, and this is kind of a much more controlled method of getting data out, because in fact, what I'm asking the AI to return back here is just a list of things, a comma-separated list of things that it thinks are related to emergency services. So so we avoid things like prompt injections and people typing things in this box which might get something nefarious back again. So in this instance, we're saying, hey, here's this term emergency services. Here's a list of about 200 things that are just the names of some things, you know, of police stations and fire stations and libraries. If you were to look at that list of things and somebody said to you emergency services, which of those things do you think are related to that, and return them as a comma separated list? And that's all we're doing. And then actually sanitizing that list, running it back past and saying, so if there's any hallucinations in there, I'm getting rid of them. So I'm checking it against the original list again. Now that's a much safer and much more controlled way of getting information, getting an interpretation.
Okay, you've done kind of a cross-validation, to use a term that geospatial people are familiar with from learning how to do kriging. Right, it relates to cross-validation. Okay.
As soon as you start asking, like the other demo asks you to write, I ask it to write part of a URL, and I'm sending that URL to a service and getting some information back. So there's always a chance that something nefarious could be in that URL, or something bad. You know, luckily the worst I could do is like have an invalid call to the OpenStreetMap database. But if you weren't careful, you know, you're in the realms of injecting things which return data you didn't want returned within that kind of thing. Whereas this, I just use the comma separated list that it returns to get some to build my own call to that database and write something back, and it's sanitized. It also, you might notice that it's returned some objects on the map, and it's also written as a fun fact about Southampton and emergency services. So this is something that, you know, you might be a bit more cautious if you're building something like this, is to put your logo against, and to put your name to, because it said the city of Southampton has a dedicated emergency services team that includes Hampshire Constabulary, Hampshire Fire and Rescue Service, and South Central Ambulance Service. And then it gives you a bit more information. So I've asked it I've given it the name Southampton. I found out the nearest town, and then said, give me an interesting fact as if you were a guide related to emergency services in Southampton.
Yeah, and I see, and again, relating to a user under stress in an emergency situation, I see you've got listen for voice commands. So does that work?
It does, yeah. Let's try that. I want to read a book.
Okay, so now it's responding, saying that it's understood Steve's asked it about reading a book, and it's now searching for locations. And
yeah, so what it's done is it's looked down the list and it's found library and museum, place of worship, and public park or garden. So those are the places that it thinks are relevant to reading books in our National Geographic database. So, and if I zoom in, you can see that all of these are kind of color coded and labeled on the map. There's a museum there, and a library, and the art gallery. So it's a good, those kind of things are like a good example of how it goes back to what you were saying about asking a human something. You know, if you're not a trained professional and you don't know our data, if you were to say, well, I want places to read a book, you'd ask a human being, and then they would go away, trawl that list, make decisions about what was the most relevant features to give you, then send you a map on a PDF or something, or put it on an online map and give it to you.
So, and this also relates to the previous episode about text to map, where we had Dario, one of the co-founders, talk about passing the grandparent test. So you've just talked to the app and it's responded with something useful. To me, I can see a whole generation of people that maybe has been confused or befuddled by what, no offense, of course, to yourself and Ordnance Survey, but overwhelmed really with the huge amount of data that you do provide the country. A simple voice interface like this, I can see really making a whole bunch of people's eyes light up. Yeah. Which takes me to another one of the questions to begin to wrap this up. So I dutifully, of course, asked ChatGPT to give me the history of Ordnance Survey. So I might read it off. It's a quick summary. It's only a couple of sentences, but it might be good to have some comment from you. But I think this question ends with trying to put AI in the context of the significant developments within the history of Ordnance Survey. So after saying that it was founded in 1791, ChatGPT came back with as the significant developments in the history of the organization, triangulation for distance measurements in the early 1800s, contour lines in the mid 1800s. It never occurred to me that contour lines were a distinct development in mapping, but of course they were, and ChatGPT says it's the mid 1800s. Photogrammetry in the early 1900s, national grid in the 1930s, computer-based maps in the 1960s, which makes sense given the MOSFET transistor, I think, came along from Bell Labs in 1958, and then GPS and satellites in the late 1900s, and then open data as the latest development in the 2000s. So in the context of these major advancements in the history of OS since 1791, would you say that the view in the organization is that AI within 50 years will be viewed as being just as indispensable to the work of OS as, say, contour lines or national grid?
Well, I can only guess at that. And I'll give you my own personal opinion. So I can't speak on behalf of Ordnance Survey for that particular question because the discussions are really, really early on at the moment. But I will say it's caused a stir. So, you know, and I think it has within lots of industries, and that is all about lowering that barrier to entry. How can it solve some of the difficult problems that there are in the world at the moment? You know, to do with health and sustainability. So bringing value to GBPLC as well. And people are taking it seriously because it's out there now. So getting value from data has always been difficult in lots of different arenas. And I think the demo's been useful to kind of build and experiment with because it scratches the surface really of what's possible. And I'm using really simple techniques here, the real basic techniques to get something out. And we're kind of pushing these Lego bricks around at the moment and trying to understand it. But I really see, I honestly see a big step change coming in the ability to get value out of geospatial data quickly and democratize that to the people who need it now. So especially, and I'll go back to the emergency services scenario, when you need an answer right now for something that's really important, you know, this kind of technique could get you somewhere, gets you somewhere right now, you know, even with simple techniques like this. Imagine what that's going to be like in the future. But if that is to happen, like across the geospatial industry, I go back to the fact that you need to have the reliable data first and you need to be able to interrogate it, right? AI doesn't solve those problems for you. And so those are things.
It can add to them through hallucinating.
Exactly. It can add to them. If you're not careful, you know, it can cause problems. So it doesn't change. What's interesting is it doesn't change any fundamental values that Ordnance Survey has, which is reliable data, which is useful to the audiences that we serve. And the fact that we need to make that data continually, we're striving to make that data more available as quickly as possible. Things like AI are just like this tool that you can use, like a user interface, like building any other user interface, on top of this like bedrock of really good data and ways of interrogating it.
So I have to say then that Ordnance Survey is in a very strong competitive position because you have, in a way, you know, the verified complete spatial data set of the country's ordnance. It was a military mission, really, or data set in 1791. That was the origin of OS, as far as I understand. So I think the industry has to expect there'll be some sort of AI-driven commercial offering from Ordnance Survey at some point.
It might not be actually from Ordnance Survey, but we might need to think about how to enable that for our partner network as well, because we have this huge network of partners that work with us. So it may be, you know, strategically there's decisions to be made. You know, maybe there's some layer that we could build which enables other companies to get value out of it using AI. But what would we need to build in order to make that as easy as possible for them? Is like one of the questions which I think, you know, Ordnance Survey and places like us, anyone who holds data is going to need to ask. You can't always build it all yourself. Sometimes it's about enabling other people to be able to do that.
No, and that's a really useful detail about some of the discussions. There must be all sorts of discussions across the industry and the country. It's really interesting to hear some insight about how that discussion is happening within Ordnance Survey. So yeah, thanks for that, Steve.
Cheers, Will.
I have one final question. I've decided to ask it of all the interviewees.
Just it's an interesting. Well, first of all, Ordnance Survey is such a big organisation. You know, there are all sorts of disciplines. So I'd be interested to hear who this mythical, like, what skills does this mythical person have?
It's a geospatial apprentice, I can say. Yeah.
Just you know, just a willingness to be creative and be interested in geospatial data and to solve real problems for people. You know, that's something that can get lost, and obviously being in a user experience team, that's really high on our list, and we talk to people about it all day, every day. And our commercial parts of the business are all about solving problems for people. So you would have to have two things going for you, which is an interest in a skill in geospatial, and a willingness to kind of steer that skill in the direction of actual real world problems which need solving.
So that's helpful, I think, because it's tempting, especially in the context of this episode, to get for your attention to be consumed by the technical side. You've emphasized the soft skills, the need to be a good consultant and listener.
Yeah, definitely.
Great. Well, that's been a really wonderful session, Steve. Thanks so much for devoting some time to the podcast and our small but growing listener base. So thanks very much.
Awesome. Cheers, Will. It's nice to speak to you. Thanks.